Hi everyone, in this video we're going to be seeing how to find the Maclaurin series or Maclaurin expansion of 1 plus x written in parentheses raised to the power of n. And so the idea here is we'll start by deriving the Maclaurin series for 1 plus x raised to the power of n. Once that's done though, I'll work through a few examples to showcase how this expansion can be used to find the Maclaurin expansion of other very important functions. So let's get started. In the upper right hand corner here, I've already written the formula for the Maclaurin series. At the top here, I've written it with the summation symbol. That's the sum from n equals to 0 up to infinity of all of this. And directly underneath that, I've written out the first three terms in that expansion. And I should say, for the sake of time and space, the expansions we'll write here will involve the first three terms of the expansion. But of course, if you want to go further and write an extra term in the expansion, you could follow this pattern to go further. All that being said, let's go ahead and find the expansion of 1 plus x raised to the power of n. So the first thing I'll do here is define my function. f of x equals to 1 plus x in parentheses raised to the power of n. And now looking at the first three terms of the expansion here, we quickly notice that for the expansion we need f of 0, f dash of 0, and f dash dash of 0. Or I could also say we need f of 0, f prime of 0, and f double prime of 0. So to make sure that we have everything we need, the first thing I'll do here is I'll find f dash of x, the derivative, and f dash dash of x, or f double prime of x. That's the second derivative. And I'll do that directly underneath here. We have f of x, which is 1 plus x in parentheses raised to the power of n. So f prime of x, or f dash of x, well, that will be equal to n times 1 plus x in parentheses raised to the power of n minus 1. And I should say, if you're unsure of how to get from this function to this derivative, make sure to review the chain rule for differentiation. That being said, I carry on and I find the second derivative, which I get by differentiating the first derivative. And I'll write that underneath here. So the second derivative, f prime prime, or f dash dash of x, well, in this case will be equal to n times the power n minus 1. So that turns into n times n minus 1 times 1 plus x raised to the power of n minus 2. Again, let me insist, if you're unsure of how to get these derivatives, make sure to review the chain rule. That being said, I carry on. Remember, we need f of 0, we also need the derivative at 0, and we need the second derivative at 0 here. So I'll evaluate each of these three functions at 0, and I'll do that right here. Let's see, we'll have f of 0, which I'll write here. F of 0, well, all that will be 1 plus 0 raised to the power of n. And since 1 plus 0 is just 1, that's 1 raised to the power of n, which is just 1. I carry on, f dash, or f prime of 0. Well, for that, I turn to this second function here. That's going to be, in this pair of parentheses, 1 plus 0 again, so that's just 1, raised to the power of n minus 1, so that's still just 1, times n. So f dash of 0 is equal to n. I carry on, and we're going to find the second derivative f dash dash of 0. And let's see, well, that will be equal to the pair of parentheses we see here, which when x equals 0 just turns into 1. And so 1 raised to the power of n minus 2 is 1 again. So we have 1 times n minus 1 times n. Or rather, n times n minus 1 times 1. So we just write n times n minus 1. There. Again, we could carry on and find the third derivative, the fourth derivative, and so on and so forth to obtain more of these coefficients. But as I said, I'll stop at the third term, and we're going to be needing these values. So I'll box those in blue. There we go. And so now, looking back at the formula we have here, in fact, I'll go ahead and copy it. We can go ahead and say f of x is equal to f of 0 plus f dash of 0 times x plus f dash dash of 0 over factorial 2. Now, because factorial 2 is just equal to 2 times 1, so that's 2, I'll just say it's f double dash of 0 over 2, which I can also write as 1/2 times f dash dash of 0 times x squared plus 3 dots. And I should say, you could write f dash dash of 0 over 2. I simply like to bring the fractions out to the front of the terms this way. Okay, now using the fact that f of x is 1 plus x raised to the power of n, and the fact that f of 0 is 1, f dash of 0 is n, and f dash dash of 0 is n times n minus 1, we can go ahead and write the Maclaurin series for 1 plus x raised to the power of n as 1 plus n times x plus 1/2 times n minus 1 times x squared plus 3 dots. And those are the first three terms in the Maclaurin series for 1 plus x raised to the power of n. Again, if you want to get more terms in this expansion, then simply carry on with this pattern over here. And I can already tell you that the next term would be 1 over factorial 3 times n minus 1 times n minus 2 times x cubed. In other words, this pattern simply keeps on going. That being said, we've now derived the first three terms of the Maclaurin series for 1 plus x raised to the power of n. But so let's move on to see a few examples of how we might actually use this. As a first example, let's say we want the Maclaurin series for 1 over 1 plus x. Well, the key thing to realize here is 1 over 1 plus x can be rewritten as 1 plus x raised to the power of negative 1. And now comparing 1 plus x raised to the power of negative 1 to 1 plus x raised to the power of n, the only difference here is that n has been replaced by negative 1. So copying the result we obtained here but replacing every n that we see by negative 1 will lead us to the first few terms in the Maclaurin series for 1 over 1 plus x. Indeed, we'll have 1 plus n times x, so that will be negative 1 times x. So I'll go ahead and write it like this, that's negative 1 times x, plus 1/2 times n minus 1. So that will be 1/2 times negative 1 times, in parentheses, negative 1 minus 1 times x squared. So let me write all of that carefully. That's 1/2 times negative 1 times, in parentheses, negative 1 minus 1 times x squared plus 3 dots. I carry on and simplify all of this. 1 plus negative 1 times x, well, that's just 1 minus x, plus 1/2 times negative 1 times negative 1 minus 1. Well, negative 1 minus 1, that's just equal to negative 2. So we have negative 1 times negative 2, which is 2. So we have 1/2 times 2 times x squared plus 3 dots. I carry on. This becomes 1 minus x plus 1/2 times 2, which is 1, times x squared. So that's 1 minus x plus x squared. And the series carries on forever. There we go. And I'll say that if you were to carry on with this series, you'll find that the next term will be minus x cubed, followed by plus x to the power 4, then minus x to the power 5, then plus x to the power 6, and so on and so forth. In other words, every even power of x will have a plus in front of it, and every odd power of x will have a minus. That being said, this is the Maclaurin series for 1 over 1 plus x. Okay, now that we found the Maclaurin series for 1 over 1 plus x, let's look at a second example, and I'll quickly write example 2 here. And maybe I'll box our previous working out like this. There we go, to separate it from the rest. Let's say for this second example, we find the Maclaurin series for 1 over 1 plus x squared. Okay, well, the first thing we'll do here is rewrite this as 1 plus x squared, in parentheses, raised to the power of negative 1. And now comparing this to 1 plus x raised to the power of n, we notice that we've replaced n by negative 1, and we also notice that we've replaced x by x squared. And so what I like to do is exactly what I'm doing here. I write what I'm replacing n by, so negative 1, and I also write what I'm replacing x by. And I do that in a pair of parentheses like this. I'll replace every x I see by x squared in parentheses. Okay, had we not already found the expansion of 1 over 1 plus x, to find the expansion of 1 over 1 plus x squared, I would use this formula and replace every n that I see by negative 1, and I'd replace every x I see by x squared in parentheses. But here, because we've already found the expansion for 1 over 1 plus x, that's the expansion we've boxed in orange here. To find the expansion for 1 over 1 plus x squared, all we have to do is copy this expansion, but replace every single x we see by x squared, and I do so by writing it in parentheses. In other words, using this result, but replacing the x's I see by my x squared in parentheses, we can go ahead and state that the Maclaurin expansion for 1 over 1 plus x squared is 1 minus, in parentheses, x squared, plus, in parentheses, x squared, squared, plus 3 dots. Now, you may be wondering why I bother with this pair of parentheses, because indeed, this first pair serves no purpose whatsoever, and I can just get rid of it. That's equal to 1 minus x squared. But for this term here, and any further powers of x down the line, I find this pair of parentheses quite useful to remind me of my laws of exponents. Indeed, this power of 2 will come and multiply the 2 that's placed as a power on the x. So this will become 1 minus x squared plus x raised to the power of 4 plus 3 dots. And there we have it. We now have the Maclaurin series for 1 over 1 plus x squared. Okay, let's look at another example, example 3. And this time, instead of having a negative integer as a power, I'll go ahead and come up with a fraction. And so let's say we need to find the Maclaurin series for 1 over the square root of 1 plus x. Okay, well again, the whole idea here is for us to be able to compare this to 1 plus x in parentheses raised to the power of n. And so for that, I'll start by rewriting this as 1 plus x raised to the power of negative 1 over 2. Now, comparing 1 plus x in parentheses raised to the power of negative 1/2 to 1 plus x raised to the power of n, the only change we can see here is that we need to replace the n by negative 1/2. So I'll go ahead and copy this expansion, but I'll replace every n I see by negative 1 over 2. And so I'll just write this on the side here. Here I'm replacing n by negative 1 over 2. So let's see, I'll have 1 plus negative 1 over 2 times x. So if I quickly write that, that's equal to 1 plus negative 1/2 times x plus 1/2 times n minus 1 times x squared. So that will be 1/2 times negative 1/2 times, in parentheses, negative 1/2 minus 1 times x squared. So let me write that. That's plus 1/2 times negative 1/2 times, in parentheses, negative 1/2 minus 1 times x squared plus 3 dots. I carry on. 1 plus negative 1/2 of x is the same thing as 1 minus 1/2 of x. And I need to add to that 1/2 times negative 1/2 times negative 1 minus 1 in parentheses times x squared. So let's see, let's take our time to not make a mistake. In this second pair of parentheses here, negative 1/2 minus 1, well, that's going to be negative 3/2. And so, although we see lots of negatives in these pairs of parentheses, ultimately we have negative 1/2 times negative 3/2. So that becomes 1/2 times 3/2. And I'll go ahead and write that. So we have 1/2 times 1/2 times 3/2 times x squared plus 3 dots. Finally, taking care of this product of fractions here, we have 1 times 1 times 3 on the numerator, which is 3, and 2 times 2 times 2 on the denominator, which is 8. So we can go ahead and state that the Maclaurin series for 1 over the square root of 1 plus x is 1 minus 1/2 of x plus 3 over 8 times x squared plus 3 dots. And that's the answer. We've now found the Maclaurin series for 1 over the square root of 1 plus x. Okay, let's look at one last example, example 4, which I'll write up here, example 4. And this time, let's find the Maclaurin series for 1 over the square root of 1 minus x squared. Well, as always, the first thing I want to do here is to be able to compare this to 1 plus x raised to the power of n. And for that, I'll start by rewriting this as 1 minus x squared, in parentheses, raised to the power of negative 1/2. And now to push this even further, to really be able to compare it to 1 plus x raised to the power of n, I don't want there to be a subtraction here. So I'll go ahead and rewrite this as 1 plus, in parentheses, negative x squared, close parentheses, and I raise all of that to the power of negative 1 over 2. And I should say you don't have to write it this way, but I would encourage you to do so, because I find it's useful to avoid sign errors in our expansion. And so comparing this to 1 plus x raised to the power of n, we can see that we're replacing n by negative 1 over 2, and we're replacing the x by negative x squared in parentheses. And so I'll go ahead and write that. I'll say n is equal to negative 1 over 2, and we'll replace the x's we have by negative x squared in a pair of parentheses. Okay, now because in example 3 we have actually already found the Maclaurin series for 1 over the square root of 1 plus x, that's the one we just found here, we can actually find the Maclaurin series for 1 over the square root of 1 minus x squared by simply replacing every single x we see in this expansion by negative x squared in parentheses. Indeed, that's the only difference there is between these two functions. The idea is, since that's the only difference there is between these two functions, well, that will be the only difference between their two respective Maclaurin expansions. So copying this result, but replacing every x we see by negative x squared in a pair of parentheses, this becomes 1 minus 1/2 of x, so that will become 1/2 of negative x squared. So let me write that. That's 1/2 of negative x squared plus 3/8 times x squared. And so replacing this x by negative x squared in parentheses, that becomes plus 3/8 of negative x squared in parentheses squared. And we add 3 dots to all of that. Now, 1 minus 1/2 times negative x squared turns into 1 plus 1/2 of x squared. And we add to that 3/8 of negative x squared in parentheses squared. And negative x squared in parentheses squared turns into x to the power of 4. So we add 3/8 of x to the power of 4. And of course we add our 3 dots to that. And let me quickly rewrite that 8 here to make it nice and clear. That's 3/8 of x to the power of 4. And there we go. We now have the Maclaurin series for 1 over the square root of 1 minus x squared. That's the result we just boxed in orange. Now, as I said at the beginning, if you're studying Maclaurin series and Maclaurin expansions, knowing this expansion is absolutely vital. Indeed, as we can see here, thanks to this expansion, we can find many other expansions, some of which will be extremely important. Examples 2 and 4, for instance, well, some of you may have recognized that 1 over 1 plus x squared is the derivative of arctan of x. So if ever we needed the Maclaurin series for arctan of x, all we'd have to do is integrate this Maclaurin series. Similarly, you may have noticed that in example 4 here, 1 over the square root of 1 minus x squared, well, that's the derivative of arcsine of x. And so to get the Maclaurin series for arcsine of x, all we'd have to do is integrate the Maclaurin series we have here. So really, knowing this expansion will turn out to be very important indeed. And I'll finish by saying that to find Maclaurin series as we did here, I would always suggest you do it in steps. In other words, I'm suggesting play it as safe as you possibly can. And so, for example, in the last example we worked through here, let's say we hadn't done any of the previous working and we had been asked to find the Maclaurin series for 1 over the square root of 1 minus x squared. Then, of course, we could use this Maclaurin expansion and replace every n that we see by negative 1/2, as well as every x we see by negative x squared in a pair of parentheses. And we'd obtain the result we have boxed in orange here. But what I would suggest you try getting in the habit of doing is simplifying the problem as much as possible. In other words, I find it much easier to find the Maclaurin series expansion for 1 over the square root of 1 plus x, that's the one we have here, and once that's done, all I have to do to find the Maclaurin series for this function is replace every x that I see by negative x squared in a pair of parentheses, which leads to this answer. In any case, we now know the Maclaurin series for 1 plus x raised to the power of n. And there we have it. There we go, everyone. I really hope that helped, and if it did, please hit like on this video, drop a comment down below, and even subscribe to this channel to help get this video to as many students as possible. All that being said and done, that's it for this tutorial.